everyone, welcome to estudy.in. So in this video we will learn some of the functions of math class. Now math class is an inbuilt class which is provided to us by Java and it is part of java.lang package. Okay, so and we don't need to import this package because as by default this is imported. Okay, so we don't need to write the import statement for this package. By default java.lang package is already part of every class. So we will learn some of the methods of the math class, and the methods of the math class are static methods. So that means we will be using the notation class name dot method name. Okay, so if you do not know what static methods are, we have covered this topic in methods and functions. So you can watch those videos to understand what are static methods. So let's start. So the first method which we are going to learn is POW. This is not A, this is P. Okay, and it is a short form for just like we have power function. So which gives you the number raised to the power. So here the short form is POW. Okay, so this function takes two arguments. Now arguments, the term should be clear, but in case you do not know what is an argument, arguments are the actual values which we pass to a function. So here when we have 2 and 3, these are arguments. Okay, 2.0, 3.0, these are the arguments. So when we make a call to the function, at the time of calling, the values which are passed to the function are called arguments to the function. Okay, so now we have this function. It takes two arguments. So parameters, we can also call them parameters. These are formal parameters. So here A is the base and B is the exponent. So that means it will return a value like this, A raised to the power B. Okay, and it will always return a double value. So let us understand through an example. So here we have math.pow 2, 3. So 2 is the base, 3 is the power or the exponent. So it will return 2 raised to the power 3. That means 2 into 2 into 2. So that is 8. So 8, since it returns in double values, it will not return 8, it will return 8.0. Similarly, if you enter two double arguments, 2.0 and 3.0, still it will return 8.0. So let us see the working of this function. So if we have here math.pow 2, 3, right, and we run this, so you see we get 8 here, right? So similarly, if you enter 8.0, not A, if you enter 2.0 and 3.0, and if you run this, so again you get 8.0 here, if you see the output window. Okay, so this is how the math.pow function works. Now the next function which we will take is Sqrt, square root. Okay, it receives one parameter, it receives one argument and returns a positive square root of A. So the return type is double. So if you see, if you write the if you call the function like this, math.square root 16, so it will return 4.0. If you write math.square root 25, it returns 5.0. So it returns the square root of the number, so that which is and it returns a double value. So let us try this out. So now instead of this, let's write math.sqrt and let's enter 16 here. So math.sqrt is 16, and if you run it, so you get 4.0. You get this value here, 4.0. Let's change it. Let's write 25. So if you write 25, the square root of 25 is 5.0. So the square root function will return a double value and it will return the square root of the number. Now the next function which we will do is cube root. So here the name of the function is Cbrt. Okay, and again it returns the just like the square root of the function, here it returns the cube root of the function, and the return type again is a double. So if in this example, if you see, when you enter 125 as an argument, it is going to return 5.0 because the cube root of 125 is 5. Okay, so 5 into 5 into 5, that is 125. Similarly, cube root of 64, what would that be? That would be 4.0 because it returns a double value. So 4 into 4, 16, 16 4 is 64. So here that is how. So if you try this example here, so if you enter Cbrt and here we enter 125, so here this will return 5.0. Okay, so that is the cube root function. Now the next function which we will discuss is ABS. It is short for absolute value. Okay, so this is absolute function. It returns the absolute value of the argument. And the absolute value means the positive value. It will always return a positive value. Even if the past argument is a negative number, it will return the absolute value of that argument, which is a positive number. So here the return time depends on the argument. So here in the first example, if you see, when you enter 4, it returns 4. When you enter minus 4, again, as I said, it will return a positive value, so it again returns a 4. And if you enter a double value, a decimal value, so minus 3.7, again it will return 3.7. So the return type varies depending on the argument, but we always get a positive value. So let us try this out. We have dot abs, and let us enter minus 4. So when you enter minus 4, and you get 4, okay, and if you enter a positive number 4, again you get 4, and when you enter a double value, let's say minus 5.7, so we get 5.7, as you can see here. Okay, so this is how the absolute function works. It returns, the return type depends on the argument type. That means whatever is the type of argument, the same type of value will be returned, but the value will always be a positive value. Okay, now the next function which we are going to take up is max function. Now max function takes two arguments, a and b. Here a and b are two arguments, and it returns the larger value of a and b, whichever is the largest number. So if you see here in this example, when we say math.max, okay, here math, m is capital, and it's not maths, it is math. Okay, do not put a s after math. So math.max 2, 3 will return 3, and again when you pass, so here it will return the larger value. So when you pass an integer value, it returns an integer number. When you pass two double arguments, it returns the bigger one, but the value is a double value. So 2.3 and 3.4, so it returns 3.4. But see the difference here, when you pass mixed arguments, that means one argument is a double and the other argument is integer. So in that case, it is going to return the larger value, but the return type would be double only. So you see, please note, when you have two values or two arguments which are of different data types, one integer, one double, then even though the max number, the larger value is 3, which is an integer, it is going to promote it to a double data type and return 3.0. So similarly in this example, when we pass two arguments, 2.0 and 2, both the values are same, there is no maximum number, so it is going to return 2 only, but it will return a double value. So when you have mixed data types, one integer, one double, so it will promote the data type to double, and then accordingly it will return the value. Okay, so we understand that the return type depends on the arguments in case of max function, and when the arguments are of the mixed data types, one double, one integer, it will return a double value only, but whichever value is greater. Okay, so let us try this out. So here, if instead of this we use max function, so when you say max 2, 3, so here it will return 3. So as you can see, 3. Okay, but when we say 2, let's say we have two double values, 2.5, 5.6. So now we have two double values, so it will return 5.6. Now here we have 2.5, and here we enter 3. So we have mixed data types. One is double, one is integer. 3 is greater, but it will, let's see what it returns. It returns 3.0. So it has returned the larger value, but it has promoted the data type to double. Okay, and when we enter two values which are equal to, 2.0, data types are different but the values are equal, so it will again return 2.0. So this is how the max function works. Okay, now the next function which we will study is the min function. Now the min function again takes two arguments, a and b, and it will return the smaller of the argument, whichever is the smaller value. And again in this case it works the same way as the max function works. So when you have 2 and 3, it returns 2. When you have double arguments, it returns the smaller one, but the return type is double now. So 2.6 and 3.4, it returns 2.6. Now here we have mixed data types. So here we have 2 and 6.7, and 2 is the minimum value or the smaller value, but the entire data type is promoted, entire expression is promoted to double, so it will return 2.0. Now if you see this example here, we have a positive number and we have a negative number. So 2 and minus 3. So minus 3 obviously is a smaller number than 2, so it will return minus 3. Now if you see this last example here, we have 2.0 and minus 3. So again, in this case, minus 3 is a smaller number, but since the data types are mixed, so here it will promote it to double and will return minus 3.0. Okay, so let us try this out. So here now, if instead of max function we use min and we say 2, 3, so it will return the smaller value, which is 2. When we mix the values, not mixing, when we put both the double types, so and 3.1. Okay, so we have decimal values, so it will return 2.6. Now we have 2.6 and we have 2. Okay, so mixed data types. One is double, one is integer. So it will return 2.0. So if you see it, it will return 2.0. Okay, right? And if you have a positive number and a negative number, so we have minus 3 and 2. So in this case, when you run it, it will return minus 3. Okay, so this is how the min function will work. Okay, now the next function of the math class which we are going to study is Ceil function, Ceil, and it receives one argument or one parameter, and it will return a value that is greater than or equal to the argument. So let's see and understand through the examples. And the return type of the Ceil function is double. So when you say math.ceil 1.2, it will return 2.0. When you say math.ceil 1.5, it returns 2.0. 1.7, again 2.0. When you say 2, again 2.0. When you say minus 2.4, so it returns minus 2.0. And when you say minus 2.7, it returns minus 2.0. So what is basically Ceil function is doing, it will always round up the values. Whether it is less than 0.5 or it is more than 0.5, it is going to round up the value to the nearest integer. So in case of 1.2, rounding up will return 2.0. So 1.5, again it will round it up to 2.0. 1.7, rounding up to 2.0. So Ceil function will always take the value up to the next integer. Okay, and it returns a double value, that is why we are getting 2.0 and not 2. Similarly, in the case of a negative number here, minus 2.4. So what is the closest integer which is larger than minus 2.4? So on a number line, you can draw a number line and you will see that minus 2.0 is closest integer which is greater than minus 2.4. So that is why we are getting minus 2.4. Right? And similarly here, if you see minus 2.7, so which is the closest here, which is greater than minus 2.7, that is again minus 2.0. Okay, so let's try out this example. So here for math.ceil, we have, if we say math.ceil 3.4, and now when we run this, we get 4.0. So if instead of 3.4 we say 3.7, so again we will get 4.0. So if instead of this we say 3.5, so again we will get 4.0. Now if I say minus 3.5, okay, so minus 3.5, so we will get the larger number, which is minus 3.0. So had it been something else, 3.2, again the closest integer which is greater than minus 3.2 is minus 3. So we will get minus 3.0. So that is how the Ceil function works. So you can remember that Ceil means up, ceiling is up. So we have ceiling, and so ceiling is up, so it will always up the value. Okay. Now the next function which we will discuss is similar to Ceil. It's opposite of Ceil, and it is called floor. So ceiling is basically upping the value, taking up the value. Floor is to bring down the value to the closest integer. So again, the same thing, just like Ceil. So we have 2.3, so it will bring down the value to the nearest integer, that is 2.0. 2.7 again, 2.0. 2.5, 2.0. Now minus 2.3, which is the smallest integer which is less than minus 2.4. So that is minus 3. So since the return type is double, so it will return minus 3.0. Similarly, minus 2.7 will return minus 3.0. So let's try it out. So now instead of Ceil, let me give a value here. Let me change the function flow. Okay, so minus 3.2. So which is the smallest integer which is closest to minus 3.2. So if you say minus 3.2, closest which is smaller than minus 3.2 is minus 4.0. So if I simply write 3.6, so this smaller one would be now 3.0. Okay, so if you write 3.2, so we get again 3.0, right? So this is how it works. The next function which we are going to take up is the round function. Now round is a little different from ceiling and floor. Now ceiling, the value is always rounded up, and floor, the value is always rounded down. Now round function actually works like the way we round up values in math. Okay, so what in maths, so what we do is basically if the number is greater than 0.5, if you have in the decimal part, that means after decimal part, if you have a digit which is greater than or equal to 5, then it is rounded up, else it is rounded down. So the same way it will work. So it receives one parameter or one argument, and remember that the return type of the round function is basically an integer value, but there's a slight catch here. If we pass a double argument, then the return type is long. Okay, so if you pass a double argument, then the return type is long, but if you pass a float argument, then the return type is int. So that is why the value of the argument rounded to the nearest integer or long value. So in round function, if you pass a double argument, then the return type is long. If you pass a float argument, then the return type is int. So here, this argument, since we have not put an f here, so it is understood that it is double. By default, Java takes it as double. So math.round 2.3. So because it is less than 0.5, so it returns 2. So again 2.5 will return 3, 2.7 will return 3. So let's try it out. So here we can try out math.round, and we will write let's write 2.3. Okay, so when you write 2.3, you will get 2, and when you write 2.5, you will get 3, and when you write 2.7, you will get again 3, right? So this is how it works. Now the next function which we are going to talk about after round is rint function. Again, it takes a double value, and this is slightly different and returns a double value. It is slightly different from the round function. Now the rint function, firstly, it will return a double value as we have seen here. Okay, it will always return a double value. Round function, whereas on the other hand, when you saw, it returns a long or an integer value. Okay, so the first difference between round and rint is that a round function will either return a long or an int value, whereas the rint function will always return a double value. Right? Now the next difference comes here is math.rint 2.3 returns again the same. In some situations it will work the same way as the round function. So when you say 2.3, it will return, because it is less than 0.5, it returns 2.0. When you say 2.7, again, because at 0.5, after 0.5 we have a number which is greater than 5, 2.7, so it rounds it up. So that means if the decimal part is less than 5, it is rounded down. If the decimal part is greater than or equal to greater than 5, it is rounded up. So, but the difference comes in when we how it differs from a round function is when you have 2.5. That means 0.5 in the decimal. So when you have 0.5 in the decimal, it will always return an even number. Okay, just remember this. When we have 0.5 in the decimal, it will always return an even number. So when you have 2.5, it will return 2.0. When you have 3.5, it will return 4.0. Okay, I think that should make sense, and let me repeat it again. When you have 0.5, okay, so it will always return an even number. So 2.5 will become 2.0, that's an even number. 3.5 will become 4.0, that's an even number. In all the other cases, it will work exactly like the round function, wherein if the value is less than 0.5, it will round it down. If the value is greater than 0.5, it will round it up. So let's try out this example. So we have this math.rint. So when you say 3.4, so 3.4 will return 3.0. Okay, so when you have 3.7, again it will return 4.0. But when you have 3.5, so it will return a closest even number, so which is 4.0. But here when I write 2.5, again because we have 0.5, so it is going to return even number, so which is 2.0. So that is how the rint function will work. Okay, now the next thing, the last topic of this video, is math.pi. Now math.pi is basically a static and a final variable which is defined in math class, and pi has to be written in capital. So it is a static variable because we are using class name dot variable name, and it is final. So it's a constant which is defined in math class, and we cannot change its value. And what is the value of pi? 3.14. So that is what, whenever you want to use the value of pi, instead of, because we do not have the pi symbol in Java, so instead of writing 3.14, you can use this variable math.pi. So let's see an example here. So let's suppose I take a variable double r is equal to, let's say the radius is 5. So we want to print the area of a circle. So we'll write math dot. So when you say p, so you get pi into r into r. So it will print the area of the circle pi r square. So when you run it, you should get this. This is the answer. Okay. So this is how math.pi can be used whenever you want the value of pi. Okay. So that is it for this video, and I hope you like the video, and please don't forget to click on the like button and do subscribe to the channel estudy.in if you have not already done so, and thanks for watching estudy.in.